Problem 3. Draw a PDM network for the following project: PDM precedent diagramming method or activity on node AON. The information for this problem is similar to the same as the problem 1 that asked you to determine the project schedule with the activity on arrow AOA or arrow diagramming method ADM. And in that problem 1 of today's lesson, you determine that project duration is 16 days. If we do correctly with the PDM network, we can be able to determine with the same amount of time for the project duration, which is 16 days. So let's do that. Unlike the activity on arrow, which is iterative process when you draw diagram, and you can see in this problem, and then I suggest you to practice in the next problem, problem 4. Drawing the diagram for the PDM network is much easier. So one box for one activity. So let's go for this. Activity A, non-predecessor. So you can draw one box. Activity B, follow A, C, follow A. So you draw another 2 boxes for each B and C. B, C, and this is A, and C follow A. So it starts from the left side of A to the right side. Start from the right side at A to the left side of C. Similarly, the right side, B follow A. So that right side of A to the left side of B. And then you have D and E follow B. So we have D and E. D and E follow B. D follow B. E follow B. And then we have F follow CD. F follow CD. So we can have F follow C and F follow D. And then we have G follow EF. G follow EF. So we have activity G follow F follow E. And that you can see draw in the network for PDM network is much simpler. And then we can plug in the duration for each activity. So duration for A 2, C 3, 6 is 6 days, D 1 day, E 6 days, F 3 days, and G 2 days. And when we have that, we can do the backward, forward, from left to right, and forward to fill out the early start and early finish, with early finish equal to early start plus duration, and early start of the successor equal to the maximum early finish of the predecessor, EFI. So from that one, and always start at 0 for the first activity. So that is 0 early start for A, and then forward from left to right, the early finish of that A equal to early start plus duration, 0 plus 2 equal 2. And then the early start of successor equal to the maximum of early finish of predecessor, EFI. So we have that 2 here. Then it will be 2. It will be 2. And then we forward just same as AOA, addition and maximum. 2 plus 3 equal 5. 2 plus 6 equal 8. Then we have 8 there, 8 there. For D, 8 plus 1 equal 9. For E, 8 plus 6 equal 14. And now for F, we have two arrow get in because two successor. So we need to get the maximum. That is 5, 9. So it is 9. So 5, 9, the maximum equal to 9. 9 plus 3 equal to 12. 12. And then G, go to G, you have two paths because G follow both F and G. So you need to get the maximum. This is 12. It go from F to G. Go E to G, it will be 14. So you will get maximum 14. Plus 2, you have 16. So then you see the same at the problem 1, project duration is 16. Now go backward. Go from right to left, and from backward to determine late start and late finish. Late start of predecessor equal to the late finish plus minus duration. So backward minus and minimum. Late finish of predecessor equal to the minimum of the late start of successor. So with that one here, we can go backward, subtract and minimum. Before we move from the early finish to late finish. So that one here, you get 16. Then go backward, subtract. So you have 16 plus 2 minus 2 equal 14. So it will be 14. It will be 14. For F, 14 minus 3, so equal to 11. 11 here, so you will have that 11. For D, 11 minus 1, you have 10. For E, 14 minus 6, you have 8. So you have that is 10, and you have 8. And go backward minimum, so you have 8 in here. And F, go back to C, you have 11, so it will be 11. 11 minus 3, you have 8. So go to A, you have two routes, AC and AB. So C back to A, you have 8 in here. B, 8 minus 6, so you have 2. 2. And then you have 2 in here. So minimum, it will be 2. 2 minus 2 equal to 0. And that's good. When you have the same early start, late start, the same. Early finish, late finish, the same for the start activity A and the finish activity G, then you're good. In the next video, for this problem, I show you how to determine the top float, free float, and the critical path and critical activities.